Hi and welcome to this lesson on fractions, decimals and percentages, but from tables. Yep, in a previous video we looked at the idea of how to turn fractions into decimals, into percentages, and what that was all about. One of the great things in maths though is that they actually give you information in tables, and it's important for you to be able to extract stuff from those tables and find fractions, decimals and percentages. And once again, we are not talking about the type of tables that you sit at. That is possibly the worst picture of a table I've ever drawn in my life, but we digress. So the key questions for this lesson are: what is a fraction? What is a percentage? And how do I read the correct information from a table? Now, information can be expressed to us in all sorts of different ways. This one here is called an infographic. Why? Because it's a graphic with lots of info, right? We don't always have to put information in pages and pages and pages and pages of text, right? It doesn't really work on lots of things, and our brain likes different colors. Our brain likes to see information in different ways. What about this one here? This one here is obviously giraffes and orangutans and monkeys, and talking about how many, or showing us how many are in San Francisco Zoo against LA Zoo. Just by looking at it, we can get some various information. And they actually say that a picture saves 1,000 words. So a picture saves 1,000 words. Because to try and explain everything in this graph here or this infographic, well, it might not take 1,000 words, but it would take a lot more than we do when we just look at it. And that's not just the only way. We can have things here called like tally charts, and hopefully we'll notice that the information's about the dogs, cats, hamsters, guinea pigs. Maybe there was a survey on which pet was owned by random people as they walk past the street. This one here has got information about the AFL, the Australian Football League, in regard to the points and percentages, and unfortunately I'm not a great lover of the AFL, or certainly don't follow it in any great respect to understand what these percentages are. Maybe one day someone can explain that to me. But maybe one of the most exciting and interesting things is when we get ideas of tables like this one here, where we have apples and bananas and oranges and pears and boys and girls. Now, what does this table show us? Well, it shows us the information about the number of boys and the number of girls who like 4 completely different fruits. And reading that information and being able to do something with it is actually really important. So, here is a table. Let's just take out some basic information first, because being able to read this is really important. So, how many boys liked apples? Well, the table is actually asking us to effectively look at our column of boys, which is this one here, and our row of apples, and see where they meet, they intersect. And as it turns out, we can read off the table that 11 boys like apples. Job done. It doesn't say anything about writing it as a fraction or a decimal or as a percentage, and maybe in this case that doesn't actually make any sense, because all we know is that boys and apples, there are 11. What about how many girls like oranges? So we're looking at the girls column this time, and now the number of oranges, and you'll notice I put circles around things just so I know which one I'm looking at. And so my answer to that is 13. They try and throw in curveballs to questions that try and trick us. How many boys are there altogether? Well, that's just asking us, we've met this type of question previously, but that's asking us to add together 11 and 14 and 16 and 9. Now, I don't know about you, but I could be sitting here trying to do this column and 0 plus 4 and 4 plus 6 and 6 plus 9. But sometimes there are actually easier ways of doing this. So, for example, if I take the number 11 and the number of 9 and put them together, I know 11 and 9 makes 20. And if I look at the numbers 14 and 16, I happen to know that they go together quite nicely as 30, which makes adding all of them together quite nice, because I just do 20 plus 30, which gives me 50. Today I was doing tennis coaching and happened to look at the number of games, and I got 6s and 1s and 2s and 4s, and it was so many numbers to add together. But what I tried to do was find all the 6s and 4s that went together, and they made 10, and I found all the 5s and 5s that went together and added them to 10, and it actually was a lot quicker. So sometimes with maths, finding number tricks helps us. How many students were there all together? Well, this time they weren't talking about just the boys. They're now talking about students. So we now know there are 50 boys. We have to do the same thing for the girls. So we're looking at 17 and 8 and 13 and 12. And again, I know that 8 and 12 make 20, And 17 and 13 go together quite nicely to make 30. Add those together, there were 50. Oh, how many students liked pears? Again, subtle change in the words. Then now they're interested in students. They're not saying boys. They're not saying just girls. They're actually looking for students. And because students includes both boys and girls, we will add the 12 and the 9 together here. So 12 and 9 makes 21. Wow. Right, so that's just reading information from the questions. But a lot of that information can actually help us try and write these in terms of fractions, again, when the question tells us to. So making my screen a bit smaller so I can keep the table on the screen. This says, what if we were asked for fractions? So, for example, what fraction of the boys liked apples? So what fraction of the boys liked apples? Well, I'm looking at how many boys liked apples. There are 11 boys liked apples, out of how many boys in total? So 11 over 50. Why is it over 50? Remember, that means out of. So 11 out of 50, which can be written as a fraction. Can I write that as a percentage though? Well, possibly, but the question is quite clear that it wants it as a fraction. What fraction, again, fraction of the girls like oranges? Right, well, we're looking at girls and oranges, so that's 13, out of the number of girls in total. And again, we'd already worked that out. Could we work this out as a fraction, as a percentage? Well, yes, we could. But again, the question doesn't want me to do that. It's going to leave it as a fraction. Now, we need to be careful that we've cancelled these down into the lowest possible form. And looking at the number 11 out of 50, which is the one we just did a moment ago, I know that number 11 is a prime number. Basically, it can't go any lower. It can't be divided by another number other than 1 and itself. And likewise, I know that 13 is also a prime number. So, because that can only be divided by 1 and itself, it can't go any lower. It's really nice to actually learn the prime numbers because it sort of helps us cancelling down, or at least knowing when we can't cancel things down. What fraction, once again, of all the students were boys? So looking at this question here, what fraction of all the students were boys? So how many boy students were there? There were 50. Out of how many students were there? There was 100. Yes, this one here can be cancelled down. I'm actually going to divide by 10 first. Why am I going to divide by 10? Well, because they all end in a 0. Now, I don't know about you, but some of my students turn and go, oh, I'm just going to get rid of a 0 when I divide by 10. Stop! Don't do that. All right, so I'm just going to explain why. Yes, maths has some great shortcuts, but it also has some bad tricks. So, for example, if I have 0.3 and I divide it by 10, well, what are you going to do? There is no 0 to knock off the end. So that trick doesn't actually work. If I had 0.260 divided by 10, well, that does have a 0 on the end. But because it's a decimal point, if I actually get rid of that 0, well, 0.26 and 0.260 are actually identical. They're the same. So knocking that 0 off the end is really bad. So my advice to you is use bouncing decimals, of which there is a video on this channel to use for you to be able to have a look at. But anyway, we now go back to what fraction of the students like pears. And we go back to what fraction of the students liked pears. So we need to see how many students liked pears. Well, we already did that. That came out to be 21 out of the number of students in total. Now, again, it's interesting because the questions, the words in the question actually help us. So if we look at this top number, it was students and pears divided by just students. This one here was girls and oranges. And this one on the bottom was just the number of girls. This one here was boys and apples. And on the bottom was just the number of boys. So the question actually tries to help you as much as it possibly can. Now, remember that a fraction can be written as the thing I'm being asked for on the top. And that was what I was saying a moment ago. If you listen to the way I was doing it, what fraction of all the students were boys? And I was saying the number on the top were boy students divided by the number of students. And I've just realized I could actually take that down a little bit further by dividing by 5 and dividing by 5, which gave me a half. I did that deliberately just to see if you were noticing. So fractions are really important. This total number of things on the bottom, this bottom number on a fraction always has to be bigger than the top. So there we go. That was that. Here are some questions for you to try. Pause the video. Have a go, and we'll go through the answers in just a moment when you unpause. All right, so how did you get on? Right, what fraction of people like purple as a colour? Now, the great thing about this table is it gave me a total of 100 on the bottom. So what fraction of people like purple as a colour? There were 10 people out of 100, which I can cancel down to 1 over 10 by dividing the top and the bottom by the same number, which is 10. What fraction of the people like green as a colour? So fraction was 40 out of 100, which is 4 out of 10, which cancelled down even more to 2 over 5. What fraction of people like red or black? Oh, now there's an interesting thing. So the number of people who like red were 20. The number of people who like black were 30. So if they liked black or red, I actually add those together to give me 50. So that becomes 50 over 100, which gives me 5 over 10, which can cancel down to a half. And I'm sure many of you knew that. What percentage of people liked red as a colour? Well, red as a colour was 20. So, oh, hold on a moment. They're trying to trick me. Did you see that there? It was a percentage. Right, so percentage. Do the working out over here. Percentage was 20 out of 100. Did you see what I did there? Did you hear what I did there? I went out of 100. Because we know that anything that is out of 100 can just be written as a percentage. And so the answer to D would be 20%. Whoop, whoop. 50 girls and 50 boys were asked to do their favourite animal was, or asked what their favourite animal was. The results are shown in that table. Use the table to answer the following questions. What fraction of boys like unicorn? Okay, so we want fraction of boys. So we're looking for boys and unicorns divided by the number of boys. So boys and unicorns was 2. So there were 2 boys who like unicorns, but how many boys are there? Well, they didn't give me the answer, so I'm going to do 5 and 15 and 25 and 3 and 2. Well, those 2 numbers there make 20. Those 2 numbers there make 5. 25 and 5 makes 30. And if I add those 2 together, I get 50. So there are 50. And I can cancel that down to 1 over 25. What fraction of the girls like cats? Okay, fraction of the girls like cats. 20. So 20 over 50. Now, you're going to say, why didn't I add up the cats? Well, funnily enough, the question actually gave me the information. How many of you were screaming, going, no, you didn't need to add up? Again, always read that question to make sure that you get the right information. So, girls liked cats, we said was 20 over 50, which is 2 over 5 cancelled down. What fraction of the girls like unicorns? All right, fraction of the girls like unicorns. There were 4 girls who liked unicorns, so that became 4 over 50, which was 2 over 25. Can't cancel that down anymore. What fraction of the students liked horses? Now, because it's talking about students, we want to do the number of boys and the number of girls added together. So the number of students who liked horses was 25, 35, 40 out of, now there was 100 students, which made 4 over 10 or 2 over 5. Wow, running out of room here. So let's do E here. What fraction of those spoken to were boys? Well, there were 50 boys out of 100 students, which cancels down to half. Hopefully you did well. All right. Hopefully you've got the understanding here of how to read things from tables. It's been good having your company. I look forward to seeing you next time.